Let's now look at conv3d transpose. And as usual, we'll first create the arrays, the input array and the filter. So for input, let's see what shape we have, and same as what we have used in conv3d, and that is batch, depth, height, width and channel. So let's paste that here. Next we need the shape for the filters. So filters, and for this let's see what shape we have, and it is depth, height, width, then output channels. After that we have input channels. So this is important to remember, that we have, after the width we have output channels and not in channels. So in channels is at the very last of this particular dimensions. So first we'll create an example, a tensor x is equal to tf dot constant, and because this is three-dimensional, we'll create again a 3 by 3 matrix, but then we'll add some more values to it. So the first one, let's say this is going to be 1 comma 1 comma 1, again 1 comma 1 comma 1, and we're using these values to keep it simple, and then we can print the shape of x dot shape, and we see that it's a 3 by 3 matrix. Now what we can do next is we need to add the batch dimension of 1. So we'll add a square bracket here that should create a batch dimension of 1. So we now have 1 by 3 by 3. Next, so we also need to add the depth dimension. So I'm going to add another square bracket there. And so now we have 1 by 1 by 3 by 3. So that's batch, depth, height and width. Next we need to add the in channels, and for in channels it's on the right side, so we can add square brackets around each of these values that we have, and this should give us the dimension for in channels as 1 right now, because we just have one value in here. What we can do is we can add more values here. So let's say the first channel has values of all ones, then the second channel has values of twos, third channel has values of threes. And so we'll go on and add 2 and 3 to each of these inner square brackets, like so. And that should create three channels uh, uh, inside of our tensor. And I'm going to copy and paste that all the way right here. And if we run this now, we should get the 5 dimensions: 1 for batch, 1 for depth, 3 by 3 for height and width, and 3 for channels. With that said, next what we'll do is we'll create the filter. So filter again is going to be a tensor, but with a different set of dimensions. We have the depth, that is first, because there is no batch is not needed here. We just have the depth, height, width, and then we have the output input channels. So inside of this we'll first create a uh, simple array or simple tensor of 2 by 2, and let's print the shape of this. Print f dot shape, and we have a 2 by 2 tensor. That we need to add a dimension of 1 for depth on the outside. So let's do that. Let's add the dimension on the outside of 1. So that's 1 by 2 by 2. Now what we have to do, let's do this to make it easy to visualize. I'm going to expand these and paste them out. So what we have is, inside of this dimension we have two values, and so we have the value of 2 here. Next, on the right side of this, we need to add output channels, and output channel, we just need one output channel. And so what we would have to do is we can add, so this is what we have. That's on the inside of this. We'll add the square bracket. So inside of this we have value of 1. Here we have value of 1. And so that uh, well, so we need another square brackets around these. So let's do that. Add one square bracket there, another square bracket here, and another there. So now we have the 1 by 2 by 2 by 1. So depth, height, width, and output channel of 1. Now for in channels, we need to add another uh, dimension. So that's going to be inside another square bracket around this 1. So that should add a channel of 1 next to it. So that's there. And here then what we'll do is we'll for each of these channels we'll add 3 filters. So the first filter, let's keep it 1 1 1. The second filter we will keep it as 1 2, and then we have 2 and 1. That's the second filter. And third filter will say it is 1 3 and then 3 and 1. So now when we run this, we have the 3 channels right there. So if we want to visualize these individual channels, we could pull those values. You can say index 0 for depth, index height, depth, and then we have all the height, all the rows, all the columns, and we need it from channel number 0. So that's going to be 1 1 1. So we can say dot numpy next to it, and what that will do is it will give us just the numpy array. We have 1 1 1, that's from the input. If you put a value of 1 there, we should get all the 2's, that's the second channel. And if you put a 3, that should give us all the sorry, if we put a 2, that should give us all the 3's there, that's the third channel. So well, that's the input. And likewise, if we look at the filter, and in filter we do not have this additional dimension, so we delete that. Again here, if you look at the value of 0, sorry, this is going to be, we have the height, width. Now output height 0, height, width, and output channel is let's keep that as 0. And then the in channel, let's look at 0, and that's the filter we have for the first channel. And if you look at 1, that's 1 2. So I don't know if you can see this. uh, so we have 1 2 2 1, that's the second filter. And then if you look at the value at index 2, we have the third filter, that is 1 3 3 1, that's for the third channel. So with this setup, we before we run the write the code, let's try and do this manually. I know it's going to take a bit while, but it's a good practice. So what we'll do first is we'll create the 3D tensor, and then create the 3D filters and perform the calculations manually as we did in the previous video, and see how it goes. So the first channel, this is the first channel. We have all the values that are 1. So this is going to be 1 1, and this is a 3 by 3. So we know that it's all of these are 1, and I'm thinking of these squares as pixels, each of them having a value of 1. So that's our first channel. And well, it should have been red, but I didn't use the red color. Let's why don't we try and put red color in there. So that's the red. Let's say this is the red channel we have. Next we'll create a green channel, and after that we can go ahead and create the blue channel. So that is there. Next we'll create a green channel, and this has a values of 2. So all the pixels in this have value of 2. So I'm going to put a value number 2 in all of these squares. So this is all 2, and this is also 2. Finally, in the third channel, we have a value of 3. So let's put a value of 3. Let's put a value of 3 in all of these squares. And there is a last row, so I'm going to put square there, put a value of 3, and finally we have this one as 3. So those are the channels that we have, and it's now time to create filters. Let me just put all of these ones in the color red. Okay, now for creating the channels, again for red we are going to use sorry, filters. Red we are going to use a filter that has a value of 1 for everywhere, and then the second one is for the green. For green we create a filter that has values of 1, 2, 2 and 1. Finally, for the third channel we have other filter that has the value of 1, 3, 3 and 1. Now based on this, what we are first going to do is create an intermediate output, and that output, so here's how this is going to work. What we'll do is we'll take this pixel, multiply multiply the value of 1 with all the values here and put that right here. So the first when we multiply 1 by all the ones, we are going to get a 1 in the output. So this is all going to be ones. So these are all going to be 1, right? So 1 multiplied by 1, 1 all these values are going to be 1. Next we take this value of 1 and multiply it with all the values in the filter, and again when we multiply we are going to get a value of 1 in all the cases. So this is again going to be all ones. And next we look at this particular 1, multiply it with the values in the filter, and we again get all the values that are 1 here. Likewise we repeat the steps for all these squares 1, 2, 3, 4, 5, 6. I'm simply going to go ahead and draw these out. So that's the ones all here, and then we have the 1 right here. These are again ones, and then we have this particular set of 4 squares that has a value of 1. So we are done up to here. Now let's look at this square that again would have a value of ones. So we multiply that one by all the ones in the filter, we get a value of 1 right here, and we move to the next adjacent square, which is this one, and then again when we multiply we get value of 1. Finally we come down to this last square, and there again we have value of 1, 1 for each of these. So that's our first intermediate output for the red channel. Then we have the second one. In this case, now we would have to do some calculations because in this case the values are a little different. So the very first case, let's draw the square. Now what we are doing is we're taking this particular value from this square, that is 2, and multiplying it with this filter, and then putting those values right here. So 2 multiplied by 1 is 2, 2 multiplied by 2 is 4, 2 multiplied by 2 is again 4, and 2 multiplied by 1 is 2. Right? And so this is going to now repeat over, it's going to repeat for 3 times in that row. So we have value of 2, 4, 4, 2, and then again we have this particular square which would have value of 2, 4, 4 and 2, and then we keep going. We have this particular square, and again here we have a value of 2, 4, 4, 2, and then we come down here. Again here we have value of 2, 4, 4, 2, and then finally we come down to this square where we again have value of 2, 4, 4, 2, and now we are at this square, in the last row or bottom row, and again in that we have value of 2, 4, 4, 2, and again here we have value of 2, 4, 4, 2, And finally, in this particular case, this last cell we are at now, we again have the value, same values, 2, 4, 4, 2. So that's our second channel. Moving on to the next channel, we have the blue channel, and in blue channel we first look at this value in this square. We have value of 3. We multiply 3 with all the values in the filter, and we get a set of 4 values here, and these values are going to be 3. Then we have 9, 9, 3. So we move on to the adjacent pixel, and again here we have value of 3, 9, 9, 3, and again we go to this particular pixel, we have value of 3, 9, 9, and 3, and so on. Now we move on to the second row. In the second row again, we look at the value inside of this. We have 3. We multiply 3 with all the values in the filter. We get 3, 9, 9, 3, and we keep going in this direction. In the next set of 4 squares, we again get the same values, 3, 9, 9, 3, and finally the last set of 4 squares in the same row, we again get a value of 3, 9, 9, 3, and now come down to this last row. The very first square again has the same value of 3, 9, 3, and so when we multiply it with the values in the filter, we get 3, 9, 9, 3, and again when we come down here and multiply all the values, we get 3, 9, 9, 3, and finally when we come back to the last square, which is this one, again this has value of 3, we finally get 3, 9, 9, 3 values. So this is our intermediate step. Next, what we are going to do, as what we have done before, is we are going to combine the values, and the way we would do that is as follows. This value stays as is, so we create a 1 and put it like so. And why don't we use the same colors? Let's stick to this color. We have value of 1, then the adjacent colors, adjacent cells, we are going to combine these two. So the 1 plus 1 becomes 2, so we put that here. Then we are going to combine these two values, and so we get a value of 2 there. And finally this one, the last one, stays as is, so I'm going to put that one right there. Next, in the following row, we are going to combine these values, so that makes it 2 there, and then we are going to combine these 4 values, so 4 values, and that 4 ones, and so the total is 1 plus 1 plus 1 plus 1, that's 4. Again we combine these 4 values, and so we get a 4 there, and finally the last set of 2's, once we combine them, we get a value of 2. And likewise we follow along and repeat the process for the row below it, and we get the same values. We get a 2, 4, 4, and a 2. Finally, in the last row we have this value that stays as 1. We put the 1 there. Then we again combine these adjacent values. Yep, so we combine those values and we get a 2 right here, and we get a 2, and finally we get a value of 1, which is going to be this one. So that's the first one. Then we repeat the process in this particular second channel as well, and here we are going to take this value of 2 that stays as is, so we put the 2 as is. Then we are going to combine these two values, and that it was 4 plus 2 is 6. We put a 6. Then we combine these two values, and again 4 plus 2 is 6, so we put a 6 there. And finally we have this value which is just 4, and so we put the 4 as is. Moving on to the next row below it, we are going to combine these two. That makes it 6. 4 plus 2 is 6. Then we are going to combine these two sets. So 4. So 4 plus 4 8, 8 plus 2 10, 10 plus 2 12. And so we put a 12. Again, adjacent set of 4s, we have these values. That again adds up to 12, so we do that. And finally we have a set of these which is 4 plus 2, that is 6, and that's what we have in the that row. And in row below it, again we repeat the same process. We have 6 followed by uh, addition of these 4 values, and that is 12, followed by the adjacent set of 4 values which are these 4 values. Again that adds to 12, and finally this, for these two values we get a value of 6. And moving on to the last row, the first value is 4, so the 4 stays as is. Followed by that we have addition of these two, that is 2 plus 4 equals 6, and then we again have a 2 plus 4, that equals 6, and lastly we have this square which has a value of 2, that stays as is. So that's the second one. So this was for this is for this one. Now we are going to create the last one. So again here we have the value of 3, so we put the 3 as is, and then we have these two values. So this is 9 plus, and it's not clearly written, but I'll try to read this. And this, so we have this 9 plus 3, and 9 plus 3 is 12, so we put a 12 here. And then the adjacent one, again we have a 9 plus 3, that is 12, so we put a 12 there. And finally we just have 9 right here, so we put 9 in the square, and that's that. Finally we move to the next row, and this is again 9 plus 3, that is 12, so we put the value of 12 in this square. And followed by that, now we are going to add these four cells. So 9 plus 9 is 18. 18 plus 6 is 24. So we have a value of 24, and let's put that there. And then again we have these set of 4 squares. 9 plus 9 is 18. 18 plus 3 is 21, plus 3 is 24, so we put 24. And again that is done. And finally in the last set of two values we have is 3 plus 9, that equals 12. And likewise we would have the values for this row below it, and it's going to be 12 for the first addition, 9 plus 3. Then we have addition of these 4 values, and that adds up to 24 just as before. Followed by a set of these 4 values. We add these, it's going to add up to 24. And finally we have these two values, that they add up to a value of 12. And moving on to the last row, this value is 9, so let's just put 9 here. And now we need to add these two values, so that is 12. 3 plus 9 is 12, so add that. And followed by that we have these two values, so 3 plus 9 is 12, and that's what we have here. And finally this cell has a value of 3, so we put the 3 right here. So that's this is the first intermediate step, second intermediate step. Now we are going to move to our final step, and in the final step what we need to do is we are going to add all of these values. We are going to add all of these values and put them on this side because there's no space on the right. So the very first is we add 1 plus 2 plus 3, that is 6. So we create a cell that is 6, and then we have 2 plus 6, 8, 8 plus 12 is 20. So we put a square, and we create a square, put a value of 20 in it. Then we have 2 plus 6 plus 12 again, so we have another 20 next to it. And the last one is 1 plus 4, that is 5, and 5 plus 9, we have a value of 14. So let's put a value of 14 as the last value. And moving on to the next row, we have 2 plus 6, 8, 8 plus 12, that is 20. So we put a value of 20 right here, and followed by that we have 4 plus 12. So we are adding this 4 with this 12 with this 24. So that adds up to how much? 12. So we have 4 plus 4, 8 plus 2, 10. So that's 30, and so this becomes 40. So that is 40, and then we add another 4 plus 12 plus 24, that adds up to 40, and followed by that we have 2 plus 6, 8 plus 12, that adds up to 20. And likewise the row below it would have the same values. So I'm just going to copy these here: 20, 40, 40, and 20. And the last row we have 1 plus 4, 5 plus 9, that's 14. And next we have 2 plus 6, 8 plus 12, 20. We put 20. Again we have a 20 next to it. Then finally we have 1 plus 2 is 3 plus 3 is 6. So this is the output we get. That's going to be our final output. So here's what we started out with. This was the input, and this was our channel 1. This was our channel 1, channel 2, channel 3. These were our filters. So this was filter for channel 1, filter for channel 2, filter for channel 3, and then these were the intermediate outputs we had. So let's type right here inter, or it should be writing it down here. So let's do that. Okay. So these were the intermediate outputs. Intermediate outputs. All of these, this one, this one, this one. So all of these. So that's the first one, and then again this was again intermediate output right here and right here. And this is going to be our final output of 3D convolution 3D transpose. Now it's time to write the code and see if we get the same output that we calculated manually. And for that, what we'll do is we'll again, as before, we'll create a variable result, and I'll keep this drawing on the screen so that we can compare it. tf.nn.conv3d underscore transpose and here we have the input is equal to x, we have the filters is equal to f, then we have the output underscore shape is equal to, we have 1 comma 1 comma 4 comma 4 comma 1. In this case we have 4 by 4, and then we have the strides, that is equal to 1 comma 1 comma 1 comma 1, and then we have the, sorry, what happened? So let's, okay, so just need to delete that comma, and then we have padding is equal to, we'll keep the padding as valid, and then we have data underscore format, data underscore format is equal to this is the batch, depth, height, width channels, that's what we have, and then we can print the result dot shape, and we can see the result dot numpy. Okay, now before we run this, I just want to check the output shape. So does the docs have anything about the output shape? It does not. It does not. Okay. Then we have we have 4 by 4. That's good. I'm thinking we do not need that. Well, let's keep it for now. Let's run this. If we get errors, we can revisit that. So while this is running, oh yeah. So the error is okay. So error is saying that the value of attribute is t is not in the list. So what it is expecting is we need this particular tensor to be of data type as float. So I'm going to type float 32 there, and likewise for the filter, this has to be data type has to be float 32. Now let's run this, and that seems so the output shape was fine. Here is the final output we get. As you can see, it should match what we have calculated manually, and we can see, so we have value of 6, 6, 20, 20, 14. We have 6, 20, 20, 14. Then 20, 20, 20, 40, 40, 20, 20, 40, 40, 20, and the same thing here. So that's what we get. And finally 14, 20, 26. We get a 14, 20, 26. So that's how the calculations would be for the 3D conv3d transpose. So you now have the intuition behind how the calculations are done, and additionally you also have a sort of understanding of how to implement that in TensorFlow. So things to remember in this case are, so let me clear the screen. So the points to remember are the shape of your input, the shape of the filters, and shape of the output. These are crucial, and if you, for some reason, if you have a wrong shape, for example, if I type 3 by 3, uh, the error would be informative to some extent. So sometimes it is, sometimes it's difficult to interpret what the error is trying to say. But if we try to follow these dimensions that are given in the docs, I think it should be it should work just fine. And so let me go back and change this back to 4 and run this again. And as you can see, the dimensions are, so these the output dimensions are similar to those that are for the input in that we have, except that we just have one here in the output for the channel. All right, so with that, uh, we'll end this video. And if you have any questions, comments, or suggestions, please do let me know in the comment section below. I hope in these past 3 videos, you got a fair bit good idea about how to perform transpose of convolutions in TensorFlow, along with the intuition how to do it manually. So I hope to see you all in the next video. Thank you.